Hello, and welcome back to the another session of Magnetron oscillator. Today, I will discuss regarding the power output and efficiency of a Magnetron oscillator. The last session, as well as the one problem related to Magnetron oscillator. Okay, so let me proceed with that one. Power output and efficiency of Magnetron oscillator. Power output and efficiency. Okay. So normally the efficiency and the output power of magnetron mainly depends on the what you call as the resonance structure. Okay, resonance structure and the DC power supply that is being applied to the magnetron oscillator. Resonance structure in the sense means, as I told you, you are having the 8 cavities in the magnetron oscillator. Each cavity I can represent in the form of inductor as well as capacitor. There I have indicated the resonant frequency. So each 8 cavity can be made in the form of a resonant circuit. That's the first point I had to discuss with respect to this efficiency as well as output power. That is, if you are drawing with 8 cavity, each 8 cavity can be made in form of resonance circuit. Each 8 cavity can be made in form of resonance circuit. Okay. So as I told you, this efficiency and output power, that is efficiency and output power of a magnetron, mainly depends on the resonance structure. Mainly depends on the resonant structure. Okay. Mainly depends on the resonance structure as well as the DC power supply that is being applied to the magnetron oscillator and the DC power supply. Okay. So I will draw the equivalent circuit for a resonator of a magnetron. That is equivalent for a resonator of a magnetron Okay, so I will draw here. This I will take as y suffix e. This is nothing but the capacitance, the voltage that is being passing here through this. I will take this point as A. This as A dash. This is the inductance. G suffix R, conductance of the resonator. This is in the form of this is G, that is load conductance per resonator. Okay, so I will call this as B, B dash. So this is nothing but load. This is nothing but from up here it is nothing but beam. This is nothing but resonator. I think it's clear for you people. So I will just introduce all the terms what I have written here. Y suffix E, it indicates the electronic admittance. V is nothing but RF voltage across RF voltage across the vein input or vein tip. Okay, I can write vein tip. C is nothing but capacitance of, or capacitance I can write it at the value tips, at the vein tips. And L inductance at the resonator. Okay. G suffix R, conductance of the resonator. And capital G is nothing but load conductance per resonator. I think everything I have included here. Okay. So we can try to derive the equation for the output power as well as efficiency of the that what is called as the magnetron oscillator. So each resonator of the slow wave structure that is being utilized in the magnetron oscillator is taken to what is called as comprise a separate what you call as a resonance circuit. Okay. So what happens, as I told you, each resonance circuit or each resonator will take in the form of a separate resonance circuit. Like that, 8 cavities. The 8 cavity will form the form of resonance circuit. Okay. So that I will write here. Each resonator of the slow wave structure is taken to comprise a separate resonance circuit. Okay. So I will write it, the unloaded quality factor, because you should procure the quality factor Q of the resonator is given by Q unloaded. It can be written as omega naught C divided by GR, where omega naught is nothing but 2 pi f naught angular frequency. Okay, angular frequency. Omega naught into C. Okay, 2 pi f c omega naught into omega naught c. Okay, okay, that's correct. Then your okay, right. Similarly, what the quality factor of the load circuit uh, load circuit is given by Q external is given by omega naught c divided by G suffix L. Okay, where GL that I have not pointed is that about load inductance, load conductance. That is I will write this as external quality factor. Okay, that is good. External quality factor of the load circuit is given by Qx is nothing but omega naught c by GL. Okay, so the loaded QL in the resonator circuit or in the resonance circuit is expressed by QL is nothing but omega naught c by GR plus GL, where GR plus GL is nothing but G external. Okay, it's clear. Then your circuit efficiency as eta c can be written as GL divided by GL plus GR, which I can written as GL divided by G external, or eta c is nothing but GL by GL divided by GR plus GL divided by GL. I just divided numerator and denominator by GL. Okay, eta c. So that becomes 1 by GR by GL plus 1. GR by GL I can write as 1 by, anyway GR already you know, GR is nothing but omega naught c by Qn. Similarly GL is nothing but omega naught by Qx. Nothing but 1 by omega naught c by Qn divided by omega naught c divided by Q external plus 1. Okay, this is clear for you. Then what else I have to do? That changes to 1 minute. Just I will verify that one. That is correct or not. That changes to eta c is nothing but 1 by omega naught c by Qn, omega naught c by Qn what is that one? Omega naught c by Qn. So this and this omega naught c can cancel. So ultimately what happens? Because I can write this thing, I can write this as 1 by omega naught c by Qn into Q external divided by omega naught c plus 1. So this and this get cancelled. So ultimately I can write 1 plus or I can write this as Q external divided by Q unloaded plus 1. Okay. So, maximum efficiency you will get only when the magnetron is heavily loaded. Okay, right then. The maximum circuit efficiency is obtained when the magnetron is heavily loaded. When the magnetron is heavily loaded, that is for G suffix L very much greater than GR. So, this heavily loading makes the tube that is quite sensitive to the load, which is an undesirable conditions. Okay. So, that I will write here, that is that heavily loading or heavy loading, I can write a heavy loading makes the tube quite sensitive to the load, which is undesirable. Okay. Therefore, the ratio Q external by Q unloaded is chosen as a compromise between the conflicting requirement of for high circuit efficiency and the frequency stability. Okay. So, I will write that one. Therefore, the ratio QL therefore, the ratio QL by Q external is chosen as a compromise between the conflicting requirement for high circuit. Okay. So, the electron efficiency is defined as, now we can define the electron efficiency. The electron efficiency is defined as eta E is nothing but Pg, 1 minute, a small variation is the Pgen divided by, where Pgn is nothing but RF power that is being induced to the anode circuit, generated power, and PDC is nothing but V naught into I naught, that is the power from the DC power supply. Okay. Divided by PDC, which I can write it as V naught I naught minus the power that is being lost in the magnetron divided by V naught I naught. So, the generator power is nothing but Pgen is nothing but RF power induced into the anode circuit. Okay. And PDC is nothing but V naught I naught, that is the power from the DC power supply. V naught anode voltage, I naught is nothing but anode current. Okay. And P loss is nothing but power loss in the anode circuit. Power loss in the anode circuit. Okay. So the finally the power generated by the electron can be written as power generated that is given by V naught I naught minus P loss, that is nothing but the power generated in the what you call as in or the RF power generated in the magnetron oscillator. Generated, one A is the power generated, sorry, I just eraser is not working properly. So anyway, I just cut this one, write it the other line. That is the RF power generated by the electron can be written as P generated is nothing but V naught I naught minus P lost. Okay. So that is nothing but V naught I naught minus P loss is nothing but I naught. I will directly write the equation. That is I naught m by 2e omega naught square by beta square plus E square maximum divided by B capital B z square, magnetic field along the z direction. Okay. So you just take this directly. Okay. No, I am not going to derive and all those things. So P generates nothing but 1 by 2 n modulus of V square omega naught c divided by QL. Okay. So where n is nothing but total number of resonators, V is nothing but RF voltage across the gap, E max is nothing but write that M1 V by L. Okay, M1 V by L is the maximum electric field. Okay, where M1 is nothing but sine beta and delta by 2 by beta and delta by 2. Okay, that is equal to 1 for small delta in the gap in the gap. Okay, gap factor for the pi mode, gap factor for the pi mode, and beta is nothing but a phase constant, and I think that all the terms Bz magnetic flux density L center to center spacing of the vane tip. Center to center spacing of the vane tips. Okay. So the power generated maybe it can be again simplified as, that is, power generated may be simplified as P gen is nothing but n L square omega naught C divided by 2 m1 square QL E square max. Okay, so you just take down directly only. So again, the electron efficiency C may be written as eta E is nothing but P gen by P naught I naught, which is nothing but generated what power is nothing but m1 minus m omega naught square divided by 2E V naught beta square. So just do the calculation for that one, how it is coming. 1 plus I naught m smaller m1 square QL divided by beta set E n L square omega naught C. Okay. So this is the equation for the generated power as well as the efficiency of a magnetron oscillator. Okay. So just calculate this one because P gen already you know. So that value I have put here. Okay. Divided by V naught into I naught. V naught into I naught already. You know the you know what is V naught and V naught what is I naught. Okay. So ultimately you will get the final answer for this one. So anyway, I will write one question for you. I will give you one example, one numerical problem, that is an expand pulsed conventional magnetron has the following operational parameter. That is anode voltage V naught is nothing but 5.5 kilovolt, beam current I naught 4.5 ampere, operating frequency f equal to 9 into 9 gigahertz, 10 raised to 9 gigahertz. Okay, so I just convert that into hertz. Resonant conductance G suffix R 2 into 10 raised to 4 mho. Okay, then what else? Loaded conductance GL 2.5 into 10 raised to minus 5 mho. Vein capacitance C is nothing but 2.5 picofarad. Duty cycle that is nothing but 0.002 power loss 18.50 kilowatt. So you have to calculate the angular resonance frequency omega, calculate angular resonance frequency, first one. Second one, unloaded Q factor, third one, loaded quality factor, fourth one, external quality factor, fifth one, current efficiency, circuit efficiency, and the sixth one is nothing but the electron efficiency. Okay, all these things I have given here. The first one is nothing but angular resonance frequency, that is omega r. I write directly the equation already I indicated that is 2 into 9 to 10 raised to 9, which is nothing, which will be nearly 56.55 into 10 raised to 9 radian. Okay. The second one is the unloaded quality factor, that is QL, equation already I given, QN, that is 56.55. You write the equation directly from that above equation, okay, what I had derived, divided by all the values, direct substitution only, you should know the values equation, okay, 707. Third one, loaded quality factor, that is QL, 56.55 into 10 raised to 9 into 2.5 into 10 raised to minus 12 divided by 2 into 10 raised to minus 4 plus 2.5 into 10 raised to minus 5. It is nearly 628. Okay, so this and all this already I have calculated in the last year when I have explained the to your seniors. Okay, the same question only I am giving here. Fourth one is the external quality factor, QX, 86.55 into 10 raised to 6 into 2.5 into 10 raised to minus 12 divided by 2.5 into 10, which is nothing but 5655. Okay. The next one is the circuit efficiency, eta C, 1 by 1 plus 5655 divided by 707, which is nothing but 71.11%. And sixth one is the electron efficiency, that is eta E, is nothing but 5.5 into 10 raised to 3 into 4.5 minus 18.5 into 10 raised to 3 divided by 5.5 into 10 raised to 3 into 4 point, which is nothing but 25.25%. Okay. So these are the direct substitution numerical problem. Because if you are having the equation what I have derived in the output power as well as efficiency of a magnetron oscillator, that directly you take that equation, study that equation, you just substitute the values what I have given in the normal question. Okay. So these are the things related to magnetron oscillator. I am closing the magnetron oscillator here. Uh, Again, so many other type of magnetron oscillator is also there, but not going to any other session because it's a wide area. According to syllabus, it is being included only up to this one. So I will just carry on with the traveling wave tube in the next video lecture. Thank you. Okay, bye.